Hello guys, welcome to my YouTube channel. My name is Fabish, and I'm a guy who deals with graph technologies, knowledge graphs, Neo4j database, or any other graph database available out there. And AI agents also. I build clients AI agents with the ability to use knowledge graphs. But today I have a different agenda for this video, because about some few months ago, I came across this article. It was talking about foundational intelligence using graph databases by Jim. So Jim here, he said, we have all seen those classic detective boards on TV made with pictures, push pins, strings, and sticky notes. This is analog graph databases, and it's used to find out who committed a crime. So basically, these boards we used in these movies, they are used for investigating crimes across different locations, states, by doing profiling of victims and profiling also of these individuals who commit crimes or offenders. So while looking at this blog posts, I wanted to try out and see if we can do this in make it a reality, took this data into a graph database and see what we get through it. Because unlike in movies where you have these boards, they're only good if the data is tiny. Let's say you're looking through maybe 100 pictures, records, or locations, then it can fit into one board. But let's say you're dealing with a city data, crime data. It's huge. Even for 1 year only, you'll find that there are millions and millions of crimes committed and reported to police crimes. And unlike movies, this is actually real world, and so maybe we can deal with some real world data and see how it works. So here he explains why do we use even evidence boards is because we are all visual learners and thinkers, and these tools help us see relationships between suspects, person, and interests, their presumed location, and evidence, and the evidence. So it is true that looking at data, because in real life we store this data in terms of tables, and looking through each table can be really painful, especially when it comes, you can't find connection between different tables. Maybe you have a bunch of documents, sheets or Excel sheets or a database in SQL, and you want to go to find out which data is related to which. It's really painful. And that's why today we try and analyze this data, import it, and try to see what we can find out from this data. So without further ado, so I'm getting this data from the FBI Crime Explorer data. I will leave a link in the description below. And so for me, I chose to select the New York data, and I will have a script to import that data into a graph database. In this case, I'll be using Neo4j, which is a graph database that stores data in forms of nodes, relationships, and basically it's actually the perfect kind of database. There are so many out there you could use, but I'm just going to use this one for this case to represent this kind of information. So you can come here, download any dataset you want. I prefer the New York dataset. For this case, if you're going to get the code in my code repository, you don't need to do all the import. I will provide a dump of this data. So we are going to do this in a series of videos, where first you're just going to import the data, take a look at simple queries. We're not even going to write a lot of queries. See some visualization tools out there. And secondly, we are going to do some analytics, because the data is really huge later, as you will see. And we will use some graph algorithms to determine certain things, do some analysis on this crime data. Okay, so the first thing, once you download this data, you're gonna have to extract it. And I have already done all that to be specific in that scenario. So you can import the data and have it, like, say, in a folder like this one. And then after that, you can run the import script here, which is in the main.py. All you need is to provide a Neo4j URI. I'm using a Neo4j desktop for this. Neo4j username and the password you use to create the database or instance. So I actually have already done all of this, and as you can see, this is a really huge data set. So 3,742 nodes, 1,000 nodes, and about 16 million relationships, 16.5 million relationships. Yeah, so once you run this file, I'm using UV, so you can just say UV run main.py and have all this, and make sure to specify the folder if you are using a different database or city. So I've chosen New York because it's huge and I hear a lot of crimes happen in New York. Yeah, so that's it. Once you import this data, you will get it in a Neo4j database. You can come here, create an instance. This is Neo4j desktop, the version 2.0. Create an instance, give it a name, then a password, and you create that instance. So for mine, I call it New York crime data. I think I have two, so I need to remove this one. This type name of the instance. So I do have two. Don't know why I have two. For now, I'm not going to delete it because I might end up deleting the actual DB. Nah. Yeah, so for now, let me leave it at that. But importing this data takes a lot of time. So if you want to use mine, I will just provide a dump. I'm going to dump it in a folder, and then you can open the dump folder, and then you can start importing that data directly. So for now, once you import the data, you can come to this tool here, query tool, and you can see a lot of nodes. In fact, like I said, it's very huge, 3 million nodes and 16 million relationships only in New York on 2023 alone. So once you import this data, we are not even going to write a lot of queries to begin with. We're just going to find out connectivity, check relationships. And for instance, I'm just going to get one of these relationships. Let me choose involve victims, and I'm going to expand this. And so we have some incidents and which involves a victim, and we're just going to do some random exploration. We're going to expand this, and then we're going to check, okay, this victim is in the race wasn't his race, or his or her race wasn't specified, but it was an offense. And if we could check this offense, the offense, it was a criminal act, possessing or concealing probably deadly weapons, I'm not sure. And this was used by a suspect, which I never cleaned this data, so I'm going to get a lot of none. But we are just doing some simple exploration here. So, okay, so the criminal act type was possessing and concealing, but it was not weapons. In this case, it is drug and narcotics. Wow. And Yeah, so I'm trying to expand, I'll try to expand on the incident and let's see what about the incident. So the offender, there was an offender in this incident, and there is also a property not really mentioned. There was also an arrestee. Wow. So as we go through and navigate through this graph, we can try some other person or victim. Let's try this one. Wow. And now we can see some interconnectedness. And later we will do some analysis on this graph. This is just simple exploration. So we have victims whose ethnicity were not specified. As you can see now, we start to interlink through the entire data inside New York. And also the race was not specified for both cases. Let me try to find another one. So there is also an incident. Okay, I thought the victim is involved in two incidences, but no. You can also check age between 45 years old. And I don't want to open the age because there's a lot of nodes connected to this, and it will, but I will open it in a few. So this was a crime, an offense that was committed against this victim, and if we expand, we will see that the offense has a motivation bias. I don't know what the motivation bias is in this case. Of course, there is a weapon here now. So in this case, we have an offense which they used a weapon against the victim, and meaning there must be an offender here. So I'm just going to check offender is in blue. Yeah. No, not that blue. This blue. Yeah. Offense type. Ooh, that is what I was trying to avoid. But now, if we look at the offense type, simple assault, we can see there are so many incidences or offenses with a simple assault. And later when we're doing analysis, we are going to find out which kinds of offenses are highly committed in New York area or city. And so we also have, we can also find the relationship between the victim and the offender, because now we know that the victim, I didn't model this actually well, but I will try to remodel it again. The victim was a boyfriend or girlfriend. Yeah, so can we check the incident now here? Okay, let me try to go through another one. Hopefully we don't open another one with that. So let's start here. Oops, no, let's start here. Okay, so let's go and try something else. Let's see offenders now. Offenders. Involves offender. Let's take that relationship. This simple exploration. And this offender, let's see. Yeah, so the offender, we don't have their ethnicity, we don't also have their race. They are 48 years old, that we know. So we now know the offender committed an offense here, or was involved in an offense. Now we can navigate through and see what about the victim in this particular incident. So there was a offense here. This offense, we can check it out and see it was about drugs and narcotics. I think this is just the same graph we had earlier. So let me try something else. So we can start with the offender and expand out. Yes, good. This one, the age was not specified. Also race, ethnicity either. So we can expand now on the incidence itself, and we can check the offense. Upon checking the offense, we can check it was a theft offense against this victim. Now here we know, you can see, and this is the kind of investigative now network we can see, and you can expand on the victim, and we can see we don't have the ethnicity or anything else, so it was just an individual. So I think this is just a simple robbery, maybe a phone. You can also see the victim's age is 21 years old. Yeah, so if I now expand outwards towards this simple graph, let me just expand on another one. Let's see. We have that. Okay, so 31 years old. Can we go to find the victim and the offense type? This is the offender. So we do not have the clearance yet. There was this. Let's find out the offense. Wow. And now we see this is it was carried out in a location, a department or a discount store. It was also a simple theft. Yeah, so as I expand this graph out, you can start seeing there are some nodes that are really getting connected. For instance, we don't know the ethnicity of either the victim or the offender. Oh, okay, so here we do have not Hispanic. So we can check which kind of victims are highly affected, which based on their ethnicity, and we can also find which ethnic group actually is highly whether we are looking for the offenders or the victim. Now this is just a 2D visualization from Neo4j query tool inside Neo4j, and it's actually really good because you can now move from one node to the other faster. And as you realize, the graph is very huge, and if you are going to do if you want to do some analysis, a specific analysis, or you might have to write some few codes later and algorithms, because as the data set grows huge and huge, you cannot just visualize about 3 million nodes and 16 million relationships. It's going to be really, unless you want to write some code to filter out, and specific you want to find out the specific locations and find out specific areas or specific crime type that have been been done on inside the city. Like if I'm going to expand this, let me just do this outside. Possession and concealing, I'm pretty sure there's so many offenses done through possession and concealing. Let's see, like I thought. Yeah, so we can't find offenses specifically because possession and concealing, and there are so many, and you can just expand through them, and you now start to see the interconnectedness. But as the graph grows huge and huger, it's becoming messy and messier. So later we will do some graph algorithms to find communities, to find most important nodes, to find out if there are offenders committing more than one offense or crime, and what is it they've been doing. And that way we can be able to profile some offenders. Maybe we can extract a simple graph from this entire graph and try to analyze from it. Yep. So this is not the only way to visualize it. I've also used you can also use GraphXR to do 3D visualization. It would have been better if they had avatars. So this is just a simple query I wrote. It's not showing. Yep. So you can see here the nodes we have and the relationships, and you can just maneuver through this, and let's make this interesting. I'm going to show relationship name. Yeah, and now we can see, just by looking at this graph, you can see how connected data always is. First, let's try to find out so this is a victim. So navigating through this is really complex, especially when it's huge, and this is where graph databases can come in, and graph algorithms, which is the next phase in this project presentation. For anyone who wants to leave a comment and say what they would like to know about this data set, please feel free to do so. But I will do some random analysis in a later video. Thank you for watching through to this point. Stay tuned for the next video, where we'll now get deeper insights on this entire data set. So thank you for watching up to now. Okay, bye.